Here we're going to talk about multiple regression with SPSS. We've talked about refractive error. Refractive error in this database refers to spherical equivalence. Think a moment for the formula. What is the formula for spherical equivalence? It is sphere plus 1/2 cylinder. So let's do a regression of refractive error. Linear regression, refractive error. And let's put in as our independent variables sphere and cylinder. We won't worry about residuals. So let's see what we get. Now we probably should have plotted this first, but that's okay. So let's look at our descriptive statistics. We have for the 4 groups the mean refractive error, the mean sphere, the mean cylinder, and so forth. We have correlations. Sphere is correlated at 0.97 with refractive error. That's pretty high. Cylinder is correlated at 0.045, at least for the Asians, which is still significant at 0.02, which seems like a pretty small correlation to be significant. But there are a lot of samples in this study. So our correlation table here has refractive error, sphere, cylinder, refractive error, sphere, cylinder. Refractive error is correlated with refractive error 1, cylinder with cylinder is 1. Let's come down. You can see that's basically the same for everybody. We also, by the way, we're not looking at just myopes. This is everybody in our database. Again, violating our assumption of independence because we have several individuals measured more than once. Let's look at our R squared. Yikes, our R squared is 1, which means cylinder and sphere account for 100% of spherical equivalence, which kind of makes sense because of what the formula is. I mean, you define spherical equivalence by sphere, even though the correlations are not 1. Okay, I don't know if that is surprising to you, but it's the truth. Let's look at our Let's look at our coefficients. So what is the formula for calculating spherical equivalence? It's the sphere plus 1/2 the cylinder. And notice the intercept here is e to the minus 15. That's about as close to 0 as you can get. 0, 0, 0. So you can see that multiple regression is actually just a reflection of the algebra in the computing of the spherical equivalence. There's no residuals. You've accounted for 100% of the variance. The minimum residual is 0. The maximum residual is 0. The mean is 0. The standard deviation is 0 for each of these groups. Which means whoever did the data recording was pretty good, or more likely the refractive error was actually computed from the actual data as being that way. So that's multiple regression.